Okay, so in this video, we're going to look at the common ion effect. If you got Le Chatelier relatively easy, this is going to be right in your wheelhouse. Common ion effect is very, very similar to Le Chatelier. So when you see common ion, I want you to think Le Chatelier. Once an equilibrium has been established, this is what happens when you make an addition to the system, which seems exactly like Le Chatelier. The only difference here is we're not necessarily adding just ions. We could be adding other substances that contain those ions. That's where you get this name, common ion effect. So this is my system that is at equilibrium. We've got a solid PbCrO4, and we have Pb plus 2 ion and CrO4 minus 2 ion. Okay, so we're going to make a couple additions, and we're going to see what happens. So first one, what happens if I add lead 2 nitrate? So the first thing you need to go is, oh, is this thing soluble? Well, yes, I know all nitrates are soluble. So what am I really adding here? I'm really adding lead ion. So because this is soluble, I'm adding lead ion. I'm really adding this is adding Pb plus 2. So what is that going to do to my equilibrium? Well, just like in Le Chatelier, if I add Pb here, it's going to increase the amount of Pb. I need to do something with it. I need to get rid of it. I need to bring that concentration back down. So I'm going to shift to the left. So if I add Pb, this is adding Pb plus 2. Therefore, shift left to relieve stress. Okay. All right. So in my next one, Na2CrO4. So is that one soluble? So we've got a chromate. Pretty sure that's soluble. Yeah, I know that's soluble. What am I doing? Yes, that is soluble. So what happens when I add this? Well, what am I adding? Adding this guy. So adding CrO4 minus 2. So what does that mean? I'm adding here. I got to get rid of it. Shifting to the left. Okay, so I feel like both of those were pretty obvious because they were represented here. What happens if I give you something that's not represented here? So I'm going to add potassium carbonate. Wow, sorry guys, brain fart. So what am I adding? This is K plus and CO3 minus 2. Well, neither of those are represented up here. But can any of these ions interact and do anything that would maybe affect this? So I'm pretty sure if I look at my solubility rules, all carbonates are insoluble except group 1A, which is soluble. That's why this is soluble, and ammonia. Well, can't the carbonate interact with the lead because it's positive and negative? Yeah. So what's going to happen? It's going to make a solid precipitate. Well, what happens when that happens? So if Pb plus 2 plus CO3 minus 2 make PbCO3 solid, what happens to the amount of Pb? I just used some of it. I just pulled some of it out. So if I use this and pulled some of it out, how does my reaction have to shift? It's going to have to shift to the right to make more of this, to bring the amount back up, to reestablish equilibrium. So adding CO3 minus 2 makes solid PbCO3, therefore shift right to increase Pb plus 2. It's a little messy, but it's there. All right. So the next one, NaNO3. So I know this is soluble. I'm adding Na plus and NO3 minus. Well, NO3 with Pb is not going to do a darn thing because it's still soluble. What about my Na and my CrO4? Pretty sure that's still going to be soluble. I'm 100% positive, in fact. So what happens? Nothing. No effect. No effect. No shift. If they're not common and then they don't do anything like make a solid, then nothing happens. They're just there, floating around, not doing anything. All right, last one. CaO solid. Okay, so I'm telling you something kind of important here. This is a solid. I'm going to drop in a solid. When I drop in that solid, okay, could it dissociate a little? Maybe. Probably not to the point where it's going to matter. It's not going to interact with either of these things because it's in a solid form. So dropping in that solid does nothing. No effect. No shift. Okay. So again, pretty similar to Le Chatelier. If you understood Le Chatelier, this should be a piece of cake. You do have to kind of watch out for this kind of situation where it's not necessarily a common ion, but it affects the heck out of that equilibrium by making a solid precipitate. But other than that, watch your shifts, think about what you're adding. You should be good to go.